Welcome to Get Your FRQ On. This question is from 2011. It's question 3, and it is not calculator active. In the question stem, we're given two functions and the graph indicates that there is a region bounded between these two functions. In part A of the question, we are asked to write the equation for the tangent line to the function f at the point where x is equal to 1/2. So the function f is 8x cubed. In order to write the tangent line here, we need to evaluate f of 1/2 and f prime at 1/2. Well, f prime of x is going to be 24x squared. If I evaluate that at 1/2, 1/2 squared is 1/4. 24 divided by 4 is 6. So f prime of 1/2 is 6. And if I evaluate the function at 1/2, f of 1/2 is 1, which means that the equation for the tangent line to f at the point where x is equal to 1/2 is going to be y minus 1 equals 6 times x minus 1/2. In part B of this question, we are asked to find the area of R. Based on the graph provided and prior knowledge of what graphs of cubic functions and sine functions look like, the graph of y equals sine of pi x is above the graph of y equals 8x cubed for this interval. We are also shown on the graph that the two functions intersect at the point 1/2, 1. So the area of region R can be found using the definite integral from 0 to 1/2 of sine of pi x minus 8x cubed dx. This is not a calculator active question, and we are expected to find the area of R, not just write the integral, so we do actually have to determine an antiderivative for this function. All right, well, the antiderivative of sine of pi x is going to be negative cosine pi x times 1 over pi, which is negative 1 over pi cosine pi x, and the antiderivative of 8x cubed would be 2x to the 4th. And now I need to evaluate this antiderivative between 1/2 and 0, and cosine of pi halves is 0, so that's convenient, that just cancels out. 1/2 to the 4th power is 1/16, times 2 is 1/8. I'm going to subtract that, so I have negative 1/8 for the top. And let's see, at 0, cosine of 0 is 1, and 0 to the 4th is 0, so I'm going to get negative 1 over pi on the back half of that. So the area of the region R is negative 1/8 minus negative 1 over pi, or negative 1/8 plus pi, or 1 over pi minus 8. There's several different ways to write it. Pretty much anything after this equal sign would be okay, given the way that they read solutions like this. In part C of this question, we are asked to write an integral for the volume when R is rotated around the line y equals 1. Notice we only need to write the integral, we do not need to evaluate it. All right, so there's two volumes that we need to consider. All right, there's the volume of the larger solid, and then there's going to be the volume of a cavity in this solid, part of it that's been carved out. All right, so we need to account for both of those volumes in order to get the volume of the desired solid. All right, well, the larger solid without the cavity carved out can be found using pi times the integral from 0 to 1/2 of 1, which is our axis of revolution, minus the function further away from 1, which is 8x cubed, squared. We're basically finding a bunch of volumes of tiny little disks. All right, so that would get me the volume for the big solid, but then I also have to carve out a portion of this solid defined by 1 minus the shorter radius, the function that's closer to my axis of revolution, which is sine of pi x. So I have pi times the integral from 0 to 1/2 of 1 minus sine of pi x squared dx. And so the actual volume when r is rotated around the line y equals x is just going to be the difference of these two integrals. So pi times the integral from 0 to a half of 1 minus 8x cubed squared dx minus pi times the integral from 0 to 1 half of 1 minus sine of pi x squared dx, which can be rewritten as pi times the integral from 0 to a half of 1 minus 8x cubed squared minus the group 1 minus sine of pi x squared dx, which should be okay. We only have to write the integral. We do not need to evaluate it, and there is no need to try to simplify this any further. In fact, my guess is if you had this expression over here, writing it as the difference of two integrals, that would probably also be okay. Can't guarantee that though, but this one over here should definitely be okay. Just make sure that you understand how to set this up as a volume of a solid, especially when part of it is being carved out. You do have to account for the missing volume.